So I'm going to talk about not only Spring Cloud, but actually about how at Pivotal and how in Spring Cloud we are testing our software. But first I'm going to say a few words about myself. So my name is Marcin Grzejszczak. I'm a developer at Pivotal, and I'm a part of the Spring Cloud team. I really like working with open source. If you go to my blog, toomuchcoding.com, then you can see some of the projects that we've been working on, including the Accurist that you have just seen, and this JSON assert thing that you saw there. And my Twitter handle is @mgrzejszczak. Okay, so what's on the agenda? So first, I'm going to say a few words that what are we actually using Groovy for at Spring Cloud. Then I'm going to move to a very short introduction to distributed tracing, because I would like to, after this talk, for you to know how we're testing this particular piece in Spring Cloud. But in order to understand how we're testing things, you should first understand what we're testing. Makes sense, at least for me. So, and then I'm going to say why Gradle makes it possible to test Spring Cloud. I'm going to show you how we're testing with Spock, and if there's time, I'm going to show you a demo. Okay, so what are we using Groovy for at Spring Cloud? So basically, in Spring Cloud Zookeeper, so the Spring Cloud's implementation of supporting Zookeeper, all the tests are written in Spock. I'm not sure if there is another project in Spring that is testing with Spock. And actually what we're also doing is that we have end-to-end tests of Spring Cloud. So in a company, we had this approach that was described here, that we didn't want to do those end-to-end tests. So suddenly I say that we're doing end-to-end tests of Spring Cloud. Yes, that's quite a bigger change, but there are reasons for that, and I'm going to talk about them later. So we're doing end-to-end tests of Zookeeper, Console, and Eureka, so the service discovery things that we integrate with. Also the Netflix tooling, so Zool, Ribbon, Feign, and Sleuth. So this is the newest kid in the block. So this is a solution for distributed tracing. So, and we're going to focus mainly on that during this talk. So to understand that, let's go through a very short introduction to distributed tracing. So nowadays, all modern applications tend to be forming a gigantic net of interconnected components, right? Everybody's like talking to everybody, somebody's joining the project and actually has absolutely no idea how the project looks like on production. It's of course not documented anywhere. And it's like tribal knowledge. That somebody, I know a guy who knows, for example, this part of the system. So this is really, really difficult. And it's crucial to have tools that allows you to visualize the system's topology and performance issues. It will be awesome to see that, for example, a request is sent and suddenly in the 58th microservice, there's a bottleneck. And actually there are tools for that. And one of the tools, Google developed something called Dapper, and it's a large-scale distributed systems tracing infrastructure. You can check a paper on about that. They're describing in a lot of depth all the infrastructure, the problems that they had, and yeah, it's a very cool thing. So there is a tool called Zipkin. Zipkin was originated at Twitter. Right now it's completely open sourced, and it's a distributed tracing system. It helps you gather data related to time of execution of requests in order to troubleshoot latency problems, right? So the idea is to, in a really fast way, get information about issues in latency related to latency and bottlenecks. The front end, which you're going to see, is like a waterfall style graph. So the bars will show you, like, the length of the bars signifies the length of a request. Now, what is Spring Cloud Sleuth? Spring Cloud Sleuth is an implementation of a distributed tracing solution for Spring Cloud. we're going to have, hopefully, release candidate 1 next week. And if anybody of you is using milestone 5, the difference between milestone 5 and release candidate 1 is gigantic. You will have to really spend some time on changing your code. It borrows Dapper's terminology, and I'm going to give you a very, very short introduction to that terminology in a second. And it seemingly integrates with Zipkin. But you don't have to actually use Zipkin in order to have to profit from some distributed tracing logs, for instance, log correlation. So what about terminology? So to begin with, we have something called a span. So what is a span? A span is a basic unit of work. For example, sending an RPC is a span. Spans are started and stopped, right? I can even rephrase that, the basic unit of work. It's a certain operation that takes some time, right? So an operation starts and needs to be stopped, and then the span knows how much time it took to start between starting and stopping. Stopping. So once you create a span, you have to you must not forget about stopping it, because otherwise you're going to blow up the whole structure of spans. So it's a basic unit of work. Now we have something called trace. So trace is a set of spans forming a tree-like structure. So let us assume that we have a bookstore. And one of the endpoints is give me a list of available books. So if I send a request, and there is plenty of things going on in the backend to retrieve those list of available books, so altogether it forms a trace. And each operation that leads you to getting the books, each of those operations can be a span. So let us assume that we have such a situation that we have a service 1 and the request comes in. So there is no trace ID, no span ID, nothing like that. A request comes in. We set the trace ID to X and span ID to A. Actually, these are not letters, but 64-bit numbers, but let's simplify the thing. So right now, this service wants to call another service, right? So another request comes, and a new span is created. So span ID is B, right? But trace is the same. So throughout the whole processing that I'm going to show you, trace ID is going to be the same, because this is one logical operation that we're doing here. And we're stamping this span with information that it's called client sent, because client sent a span. Now service 2 got the span, so it's the very same span as the previous one, but this time the server received it. So span B right now has 2 information logged, client sent and server received. Now let's say that service 2 does some operation, so another span is created with IDC, and it's calling the third service. So we have exactly the same situation. Client sent, server received. So each time a request is created, a new span is defined. So let's start coming back, right? Some operation has been finished, so span ID with ID E. So maybe I'll turn it on. So span with ID E gets closed, it's finished, and here we have to close this part of span ID with D. So server sent, it means we have to close the circuit. Client has sent, server has received, server has sent, and as you can imagine, we're going to have client received. So the whole hop from one service to another leads to 4 annotations. So client sent, server received, server sent, client received. And if service 2 called another service, we would have exactly the same bit. And we go back and return a response to the user, for example, the list of available books. So at the end, trace ID is still X and span ID is A, because it was the first one here. Does anybody have any questions to that? Okay. Another thing which is important is that I told you that spans create a tree-like structure, so a span can have a parent. So the first span with IDA has no parent because it's the first one. So the second one has the parent of this one. The third one has the parent of this one. If you go back, you can see these are the colors, the same colors, right? So this in service 2 sent 2 requests to service 3 and service 4. So the spans in service 3, he will have a parent, this one, and the request sent to service 4 will have the very same parent. It's important because we're testing that in our tests, whether the parent structure is proper. Okay, so here I'm going to show you an example. I've annotated the endpoints that correspond to those services. So we have start, foo, bar, bus. And this is the screenshot from Zipkin. So I told you that Zipkin is a software that allows you to do distributed tracing analysis. So this is the first endpoint, the first request that was sent to the start endpoint. So the longest bar is actually sending the request and receiving the response, right? So this is why it's the longest. Then you have sending of information from service 1 to service 2 at endpoint foo. And then this is processing of endpoint foo at the second service side. Then we have service 3, so bar, and service 4, bus. So here, assuming that you have such a case, you could immediately say, for instance, that if here you would have 10 seconds of processing, you would just take a look at the screenshot and say, I have a bottleneck, right? You don't even have to know the whole topology of the system, and you immediately see a bottleneck. If you click one of those spans, you will see the annotations. So, like I told you, client send, server receive, server send, client receive. Okay, so that was really, really quick introduction to distributed tracing. So, why Gradle made it possible to test Spring Cloud? What we wanted to achieve is, apart from having good unit tests and integration tests inside our libraries, we wanted to see if all the building blocks are working together. So we didn't want to write different test applications for different libraries because we would have to maintain, both actually, right? So we wanted to have something common. So one test application or test system for all the libraries. Also, we wanted to write such a solution that we could test the libraries on Cloud Foundry, which is the pass created by Pivotal, or co-created by Pivotal, because it's also a crucial product for us. So we wanted to ensure that our libraries are working there. And actually, this is what was my personal thing that I wanted to prove, because before joining Pivotal, I heard that Spring Cloud Service Discovery abstraction works like this, that if you want to change, if you would like to change from console to Zookeeper or from Zookeeper to Eureka, you just change the jar and configuration. That's it. You don't touch the code. So I wanted to be sure that actually that's the case. And we managed to do that, actually. So anybody who has been at my presentation in Shimano's last year, he saw this. It's the brewery system that we've created and we were presenting during different talks. So I just converted it to Spring Cloud and reused it for our tests. Now, it didn't look like that because I have added some additional applications. So in general, there are 5 jars. This fly is killing me, seriously. So there are 5 jars. There is the presenting service, the brewing service, Zool application, the ingredient service, and reporting service. Very fast. A user wants to order ingredients to produce beer. He clicks the UI, and a request is sent. Now, those packages are parts of the brewing service. Before that, these were separate applications, but my laptop couldn't handle so many jars executed, so I merged it together. Once somebody clicks and orders ingredients, a request is sent to the Zool proxy, which delegates the call to the ingredient service. So here, I've done this deliberately to test Netflix, integration with Netflix Zool here. Then let's say predefined number of ingredients is sent back to the user. It's always, the number is always fine. Then we're brewing the beer. And the information goes back to the presenting service that, for example, number of beers matured in the maturing process is 5, and number of beers being bottled is 10. It's like there's interaction with the user. Here, via RabbitMQ, we're sending events to the reporting service. It was because we wanted to ensure that our integration with via Spring integration with RabbitMQ is working fine, and whether our tracing instrumentalization is working fine with Spring integration. And also it was to show people that you can do CQRS, that you could do CQRS over in terms of the architecture by emitting events from applications and listening to them in their, some sort of a reporting service whose database can be prepared specifically for the reporting teams. Okay, so why was it possible to test Spring Cloud with Gradle? So we wanted to test that service discovery is working, so the applications can talk to each other. That's pretty obvious. But we wanted to do it in 2 ways, via REST template and via Feign. Feign is an abstraction over, it's a REST client from Netflix. And I had to redesign the applications that they are stateless. It means that I didn't want to redeploy the app for Feign to start working, or REST template. So actually what I'm doing is that in the headers, I'm passing information to each of the service that please use REST template as communication means, or Feign. In this way, I can test things in parallel even. And whether Sleuth is working, so which means that if proper spans were created, and if trace information got propagated between services, and if they are actually in Zipkin. So, how do we do this? I've created in Gradle a what to test closure, in which I'm checking the what to test system property. So, for instance, I can run, I'm going to show you that in a second. So, basing on the information from what to test, I'm attaching different jars. So if I want to test console, I'm attaching the Spring Cloud started console discovery. If I want Eureka, I'm attaching a different jar. If Zookeeper, a different jar. That's how I can package the application with different jars. Yeah. So these are examples of how I'm packaging the apps with different building blocks, right? Console, Eureka, Sleuth. Underneath, when this command is executed, at the end of the day, a lot of fat jars are created with proper, proper jars inside. At some point, we were using also Docker, but due to some disastrous network issues when it was combined with Docker Compose, I just almost totally removed it because it was hell. But anyways, at some point, we used also coolness of Groovy and Gradle to define a template of a Docker configuration that received as a parameter a port, and basing on that value, create some debug port and started the app on certain port. It was exposing ports and exposing also the debug port. What is very cool is that by executing this method, create Docker task with port and providing that port, I was creating a task of type Docker, and I carried in the port inside. So at the end of the day, I didn't execute the closure, but I returned the closure with an inserted port already, right? Because the Docker task requires a closure at the end. So this is where Groovy's carry comes in to the rescue. What I really liked about the Gradle setup is let's say, clear separation of configurations. So I could create lists of projects that are either Zipkin related, non-Docker projects, non-Zipkin projects. So it's obvious, clear, and concise which projects are, I mean, what part are you actually configuring, right? You cannot be more explicit, configure Zipkin related projects, right? You can read it like a book. And here you have another example that if you have a Zipkin related project and you passed in the what to test equals sleuth parameter, then you should add Zipkin. Since I'm a fan of automation, I've created a bash script. I could have done this with Sugar, for instance, and most likely I will do this eventually because it's a very, very good idea. But for now, I've created a bash script with which you just, I mean, you can clone the brewery project, you can run this script, and it will automatically build the whole, package all the applications with proper libraries, run all the required Docker Compose files, wait until all the applications are booted. It will do everything for you, including running the tests. So, coming to those tests. So, how we're testing with Spock. We wanted to run the same tests for Cloud Foundry and locally. It was really crucial that the tests needed to be written in such a way that they are parameterized like this, that I only provide the URLs and everything works out of the box, regardless whether the machine is, whether the whole setup is local or it's on Cloud Foundry. I wanted to run the same project with tests for different libraries. So if I'm testing Zookeeper, I want to run the same test project as when I'm testing, for example, Sleuth. I didn't want to clone another project. I didn't want to go to another module, whatever. I wanted to run the same things. Yeah, I needed to ensure that I'm only executing related tests because at some point, when I was trying to test Sleuth, by mistake, I executed tests of Zookeeper and they passed because Zookeeper tests were only checking if service discovery works. And I was very happy that Sleuth is working fine, whereas it wasn't. So after this mistake, I needed to ensure that proper tests are executed. So this is an example of the specification that is written. Can you see that at the end or not really? Okay. So this is an example of the specification that I wrote to test Sleuth. No, I mean, if you know Spock, you can see immediately the beauty of how clear the code is. The crucial parts are this: requires test condition sleuth. So requires is the annotation from Spock, where I want to run this specification only if you want to check sleuth, right? This is quite obvious. On the bottom part, you can see that I'm testing a REST template and feign type of communication. And that's the only, I mean, I don't have to redeploy any of the apps, just I provide in the request headers different information, and then inside the applications need to know what it means actually, right? So if I provide in headers REST template, then the application should communicate via REST template. Even though I, let's say, a little bit repeat myself in terms of the methods and let's say the labels here, like the presenting service has been called with all ingredients, and here's presenting service has been called. It's done deliberately because I use Spock reports, and I'm going to show them in a second. Yeah. So this is you saw here the test condition sleuth. So this is the closure that I'm executing, the sleuth thing. So I'm checking if the test system properties that were passed to the tests are either sleuth or sleuth stream. Sleuth stream is another way of testing sleuth, or of making sleuth propagate spans. It doesn't matter. So I encourage you to also, in your tests, to start profiting from this requires annotation, because sometimes you may run tests even though you shouldn't, right? And you were wasting time. And this is the extract from the Spock reports. Who of you is using Spock reports? Okay, quite a few people. This is awesome. I mean, this is just fantastic. So if somebody from the business side just takes a look at that, he's exactly written everything how the things are working. So here he can read it like a book. Should successfully pass trace ID via REST template and process ID. When the presenting service has been called with all ingredients, then eventually beer will be brewed with same trace ID and first request, and entry will be present in Zipkin. I wanted people who are, let's say, don't know much about Spring Cloud Sleuth and how it's actually working, go to our test reports and read how exactly it should work. And this is our screen from Bamboo. Yeah, this is a sad topic for me, but never mind. So actually I took this screen 3 times because the first 2 times I had some red builds and I didn't want to show you the red builds. So actually I'm showing you the Spring Cloud Bamboo builds where we have those end-to-end tests for different projects. So like I told you, Console, Eureka, and stuff like that, executed every 3 hours. Because I want to be sure that I mean, Spring Cloud Sleuth is reusing Spring Boot, Spring Cloud Netflix stuff. So I want to be sure that if somebody changes something in Spring Boot, it's still working, right? My applications are still working. That's why I'm running it each 3 hours. Okay, the demo. So here's the Zipkin UI. Okay, it looks like this. So let's say this is the brewing control panel. Now let's say that I want to order some ingredients. For the beer process to start, we need 1,000 of ingredients of each of those types. So malt, water, hop, and yeast. Yeast is without the typo. So I'm going to right now order only 3 ingredients, right? So I'm clicking order. I knew it. I knew it. Yes. Yeah, I'm gonna just start again. Of course. So yeah, let's go to the Zipkin. Okay, it worked. Okay. So let's see. This is an example. It looks hectic. Of how the whole beer brewing process looks like in terms of requests and their time of execution. So you can scroll down. Altogether, there are 53 spans. So 53 operations taking place to brew the beer. And there are some hard-coded thread sleeps in the code. And you can see that, for example, here. That if you go here, why the hell does it take 122 milliseconds? And I know why, because I think there's 100 milliseconds of sleep. But if you take a look at the, let's say, you run some request and you immediately see issues. You also can, let's say, go through the whole process of the business, from the business perspective. You can go through the whole process of the whole request passing through your application to see what exactly is going on, because it could take you very long hours to, let's say, go through the code, to see the method executions, to see even how some things are working in your system. And here, you have it out of the box. You can specify your own spans that, let's say, provide you with some meaningful information, like, I don't know, calculate tax or things like that that are important for you. And you can see how much time those parts are taking. Yeah, so that's actually the bit that we're testing in Sleuth. I wonder if the thing is working right now on Cloud Foundry on the web. Because I can maybe show you, because locally I had some issues, as you could see. Brewery presenting, is it alive? So this is the deployed app on Cloud Foundry. Yeah, of course, everything is working today. Never mind. It worked on my machine, of course. Yeah, never mind. So that was a fantastic demo. So summary. Thanks to Gradle, Gradle allowed us to create highly customizable project. So I've created this project setup, and only by passing system properties I can choose what I want to in the applications to end up. And with Groovy and Spock, we've created really readable and platform-independent tests. Platform-independent means that I can test the same thing on locally as well as on Cloud Foundry. And still, I'm not a fan of end-to-end tests. Absolutely, nothing has changed with that. I think they're valuable because they give you some additional feedback, but they are extremely hard to debug. I mean, it takes a lot of time to do that because everything can go wrong. But we've already found quite a few bugs thanks to those tests, which is good. I mean, not that we had bugs, but that we found them. OK, so thank you. And here are the links. This is the link to the Sleuth repository and docs. The brewery is available here. And I wrote a post on the Spring blog about the rationale behind the end-to-end tests, and that I still don't like them, but they are valuable. So do we have, no, you don't have time for questions. I mean, during the break. So thank you.